Okay, we have two more questions left, and then we're going to the skills practice. So, question number 13 asks, do atoms of different elements have different numbers of electrons? Well, yes, because they can have different numbers of protons, and so and different electrons and neutrons as well. So, yes. And then last question from the ComQuest, number 14, reads, if all of the electrons in atom A get excited and then lose their energy and return to the ground state, the electrons will let off a combination of frequencies and colors of light. Each state, each frequency and color corresponds to a specific electron, making a transition from an excited state to the ground state. Consider an atom from element B. Would you expect the excited electrons to light up the same exact color as atom A? Why or why not? Okay, well, looking at the two diagrams that I put up, you can see that atom A has more electrons than atom B. So if that were the case, then no, the colors wouldn't be the same. They would actually be different, and because the different number of electrons you have. Now we're going to start on the skills practice for this section. So we're going to go ahead and start with number 1. It asks, define the terms ground state and excited state. So looking at the picture, you can see that the ground state is the lowest point of energy we have, or the absolute minimum. And then anything above the ground state is the excited state. So it could be like a little bit more energy or a greater amount of energy. Either way, it's still the excited state. Number 2, what is the wavelength of light that has a frequency of 4.22 times 10 to the 15th hertz? Well, if we take our formula for wavelength, we know that lambda equals c over f, and if you need a refresher, c is the speed of light, which is a constant, and f is our frequency. So we're going to plug in our constant for c, and then we're going to plug in our frequency, which is 4.22 times 10 to the 15th, and we'll get a total wavelength of 7.11 times 10 to the negative 8th meters. Do not forget your units, or you're screwed. Seriously. Number 3, what is the energy of light that has a frequency of 1.3 times 10 to the 14th? Well, we know that energy is h times f, so h is Planck's constant, so we're going to plug that in for h, and then they gave us the frequency, which is 1.3 times 10 to the 14th. So we're going to put that in and multiply the two numbers, and we're going to get an energy of 8.62 times 10 to the negative 20th joules. Question number 4. A certain atom has a green spectrum line of about 540 nanometers. What is the difference in energy between the two energy levels responsible for producing the line? Well, for this problem, what they're asking for, first we're going to solve for the frequency, and then we're going to use that and plug it in to the energy formula that we have to find the energy. So first, we're going to do C equals F times W, and that converts to F. If we're solving for F, it'll be C over W. So we're going to have our constant for C, and then we're going to convert the 540 nanometers, and we're going to make it 5.4 times 10 to the 9th power. And after you do that, your frequency is going to be 5.56 times 10 to the 14th meters. And after we get our frequency, we're going to use, so you're going to take the h and multiply it by the number that we got for the frequency. And then, so you're going to get a total energy of 3.68 times 10 to the negative 19th joules. Number 5. The wavelength of a certain beam of light was 3.52 times 10 to the negative 7th meter. A asks, find the frequency of the light, and then B, calculate how much energy this light has.